In this video, I'll be talking about linked list. Linked list is the third type of ADT that we've been studying. It's a bit more complicated than stacks or queues. So first of all, let's get started with the concept of linked list. So linked list stores data in nodes. So a node has two parts, a data part and a pointer part. So the pointer here points towards the next node position, and the data here stores the data. So I'll explain this a bit more. Suppose this is my linked list. With, let's say, 5 elements. And these are their specific indexes. They store A, B, C, D, and E. Now here, this is pointing towards B, B is pointing towards C, C is pointing towards D, and D is pointing towards E. Now here, it stores the position of the next node. So A is pointing towards B, which is at index 1. So here, in our next node, we'll have 1. Now B is pointing towards C, which is at index 2. So it's pointing, so here in the next node, we'll have 2. For C, it'll be 3. For D, it'll be 4. And for E, E is the last element. So for the last element, its next node pointer is always at -1. So this is basically how a linked list works. Now, for computer science A levels, we study few things. We study searching in a linked list. We study insertion, which can be ordered or unordered. And we study deleting a node. So we're going to start with unordered insertion. So in unordered insertion, we add a new node to the linked list and we add it to the last element. So to understand this better, if we have 3 objects, 3 nodes in our linked list, these 3, I want to add a new node, which is D. Now D will be the last node. So I will add D after C because C is the last element. So automatically D's pointer will be -1. However, I would need to change C's pointer to wherever D is. So if it's at 5, index 5, I will change it to 5. If it's at 4, I will change it to 4. So this is what we basically do in insertion. Now, how do we know where it's free? So we have B, C. So here we have our nodes that already have data in it. And then we have empty nodes. For example, we have 2 empty nodes. Now they can be in any index position. Imagine all of these being stored in an array. So if I have A, B, C, then I have 0, 0, 0. So if it's something like this, my first free node is at the 3rd position. So 2, which is the last node, will point towards 3. If my first free node was here and C was my last node, then 2 would have to point towards 5. So these are my free nodes. They also point towards each other. So here, if let's take is at 5 and 6. So this is pointing towards 6 and 6 is pointing towards -1. So what I need to do is I need to take this, add the value I want to add, and then connect it over here. So for that, here we have a start pointer that points towards 0, and here we have an empty list pointer that points towards 5, which is the first position where we have a free node. So I'm going to take the element, the node at the empty list position. I'm going to take it. Then I'm going to change the data from here to whatever I want it to be. I'm going to change this to -1. Then I'm going to change this to position 5 so that it can be connected over here. And then I'm going to take the empty list pointer and point it towards position 6 because now the first free element is at position 6. So this is how inserting a node to the end of a linked list works. So the first thing we need to do is know how to make a node. So for that, we can use 2D arrays and record data type. So I will be explaining it by record data type. So I want to make a class node. This is how you use record data type. I will cover record data type further in my videos. So I want to make a class node. This part has some concepts from object-oriented programming, which I will cover later on. So just keep in mind this format. Now our node has two things. It has data. This P is for public, a public variable. This is just the name of the variable that I'm keeping. Then it has a next node. Now I'm going to define data, and then I'm going to define. So this is how I create the class node. The node here, I am going to take a node as a data type. So here I'm doing it according to this question. It's from one of the past papers. So I need to make a linked list of all of these elements. So how this is going to work is I'm going to take an array, a 1D array named linked list, and then I'm going to store, it's going to be of the data type node, then I'm going to store all of this. So this here is the data, and this here is the next node. So at 0 index, it's 1, 1. At the first index, it's 5, 4, and so on. So how this actually works is the data 1 has the next node 1. So that means this is pointing towards this. Here, the next node is 4. So this is pointing towards this. Here, the next node is 2. This is pointing towards this. Here, the next node is 7. So this is pointing towards 7. Here, the next node is 3. So it's pointing towards 3. And here, the next node is -1, which shows end of list, which is meaning the last object. Now, the rest of these, here we have 0. It's pointing towards 6. And then this is pointing towards 8, and this is pointing towards 9. This shows that these 4 are the empty list ones, which is why our start pointer is pointing towards 0, while my empty list is pointing towards 5, because 5 holds the first empty node. So first, what we're going to do is we're going to make the linked list of data type node. So now node is considered a data type, how integer is considered a data type, or how string is considered a data type. So we're going to start with 1, 1. Sorry, it's supposed to be capital N. Just change it to small n. So let's do this. Then we have 6, 7, 7 minus 1, 2, 2. 0, 6, 0, 8, 56, 3. 0, 9, 0 minus 1. So here we have declared our linked list. Then we need to declare the start pointer, initialize it to 0, and the empty list. So start pointer is equals to 0, empty list is equals to 5. So we're done with all the initializing of the variables. So now we're gonna make the function add node. So first of all, we're gonna take global start pointer, global empty list, and global linked list. Then I'm going to ask the user to input the data they want to add. Enter the data you want to add. After that, I'm going to check if there is any empty space in the linked list. So here I have a total of 10 elements. So to check if there is any empty space, what I can do is see where the empty list is pointing towards. Now, if these are my empty nodes. Oh. So first of all, my empty list will be pointing towards 4. Once this is used, it's going to point towards 5. Once this is used, it's going to point towards 6. Once this is used, it's going to point towards -1. So when we have -1, if our empty list is -1, that means that there is no more free space. Another thing we can do is check if the empty list is greater than 10, greater than 9, or greater than equal to 10. Here you can see that we have 10 elements. So if our empty list is greater than 9 or equal to 10, this will show that it has exceeded the total number of indexes. So the two conditions we can put is if empty list is less than 0 or if empty list is greater than 9. We will print linked list is full. Else, now what we're going to do is we're going to take a new variable, free list, which is equal to empty list. Now why is that? I will explain it in a minute. So what I'm doing here is, now to understand this dot next node, if this is my node and it has data and next node. So when I want to access something from a class, I write it as dot data or dot next node, or whichever name I've used to define it from. So when I say linked list empty list dot next node, what happens is if this is my empty list pointer pointing towards 5, and then this is pointing towards 6. So I have 0, 6, then 0, 8. So what happens here is that it goes to linked list, index the 5th element. So it's going to go here, and then it's going to take its next node, which is 6. So I've assigned the value of empty list to linked list, empty list dot next node. So here the new value of linked list is going to be 6, because once this is used, we're going to have empty list point towards the 6th element. Now why did I take free list? It's because once empty list has been updated, I need a variable to store this 5th position so that I can add the new node to this position. Now another step that I'm going to do is take current pointer, which is another variable, as my start pointer. Why did I do that? Because I would need to, here you can see that my start pointer is pointing towards 0, but I want to go over the whole list. So I want to go to 0 and 1 and then 2 and then 3. So my start pointer's value cannot change. It needs to stay at 0. But my current pointer will take 0 first, and then it will move to these values. So now after this, I'm going to take a new variable, which is new node, and then assign the value that I need to add to this. So data and then -1. This data is the data that we just took as input from the user. So now I'm going to add this value to the free list position. The whole node will be added in the 5th position now. Now what I want to do is, I've done all of this. I've added the value here. So now what I need to do is, I need to connect it to my previous node. I needed to, like over here, I needed to connect C to D, change its -1 to 5. So for that, what I'm going to do is take another variable, so let me explain this to you. One, two, three. So now I have a new variable E, a new data E, -1. So I want to find this, and then I want to change the 1 here to position 5. So I want this 1 to be changed to 5. So what I'm going to do is I'm going to see while my current pointer is not equal to -1, because when it's going to equal -1, that means I've found the last position. So while it's not equal to -1, first my current pointer is going to be 0 and my previous pointer is going to be 0. So first it's going to check if it's not equal to -1, I'm going to update it. How is it being updated? So current pointer is equals to linked list current pointer. Right now linked list current pointer is at position 0 dot next node. So it's going to be 1. Now my current pointer is 1. It's going to check it again. 1 is not equal to minus 1. Then it's going to go to 2. Same with 3. And as I'm moving forward, the value of my current pointer is being assigned to the previous pointer. So when it changes to 2, my previous pointer is going to stay 1. So when I get to minus 1, when my current pointer equals minus 1, my previous pointer is going to be 3. So then I'm going to use this value of the previous pointer to change this minus 1 to 5. So here, once I've found my previous pointer, what I'm going to do is linked list previous pointer dot next node. I'm going to change it to 5, which was the value of free list. So this is basically how you write a function for adding a node in a linked list. Let's just check. Let's call it. See if it's running properly. It is running properly. So now where will, oh sorry, it doesn't take a parameter. So enter the data you want to add, 10. So just to see if my data has been added, so my data has been added. Now where will my data be added? Here on position 0, 1, 2, 3, 4, 5. It's going to be added at position 5. So to check that, let's see. Wait, I should print this. So I want to add 100. And you can see that at position 5, my data is 100. And if I want to print its next node, it should give me -1. So it is giving me -1. So we can see our data has been successfully added in the list. In the next video, I'll cover how to delete a node.